Hello, and welcome to a special episode of Backer Breaks It Down, where we answer the question finally, how can I use Pythagorean triples? And so what I have here on the screen are the four most common ones: 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. So I'm going to talk to you about something called the reduced triangle principle. Once again, I must reiterate, Pythagorean triples, shortcut. That's all it is a shortcut. You can get the same result using Pythagorean theorem, but if you can recognize when you're using a Pythagorean triple, it can save you some time. So check it out. So here we have three triangles. We have a 3, 4, 5, a 6, 8, 10, a 9, 12, 15, a 3, root 3, 4, root 3, 5, root 3 triangle. What do you notice? What do you wonder? Yeah, so they're all multiples. If you were to take that first triangle and multiply them all by 2, you would get the second triangle. If you take the first triangle times 3, you would get the third triangle. If you were to take the first triangle times the square root of 3, you would get the last triangle. Okay. And so the principle of the reduced triangle says that we could figure out like what is the Pythagorean triple involved, and we could determine like what the multiplier is, and then we can apply it. So like here in this example, they want us to find the missing side. Now I can totally use Pythagorean theorem to do this. Or I can try and figure out, is this a triple? Like 10 and 24, like I can divide these both by 2 because they're both even. And when I do that, I realize 5, 12, well, 5, 12, 13 is a family. Okay, and 5 and 12, like those are the legs. So 13 would be the hypotenuse, and then double that, you get 26. And so, like, if you recognized a Pythagorean triple, like right off the bat, then you should use it to find the missing side. And if you don't recognize that a triple is being used, then use the Pythagorean theorem. But the triple can save you time. So like these are all 8, 15, 17s. Okay. Like clearly this last one, I can tell that all they did was multiply everything by 10. Because like 15 times 10 is 150, 17 times 10 is 170, and 8 times 10 would be 80. Okay. The other ones aren't as obvious. I can look at 24 and 45, and it's like, well, if you divide them, those are both divisible by 3, right? And so 3 would be the multiplier. So then if I go 17 times 3, then I'll get the missing side of 51. Okay, B is not as obvious. Like the key there is realizing that they divided by 5. So if you go like 8 divided by 5, you get 1.6. 15 divided by 5 is 3. So this would be 17 divided by 5. So that's not really obvious to me. Like, honestly, if I saw that problem on my homework, I would just use Pythagorean theorem. But sometimes it might be obvious, like, oh, this is a triple and this is the multiplier, therefore this is the missing side. Okay, so all of these, I don't tell you which family, but they all belong to the same family. Can you figure out which one? So when I look at figure A, I'm like, oh, those are both even. So like that means what if I divided them both by 2? So then this would be 12 and this would be 13. And so one of our triples is the 5, 12, 13, which means the missing side, since the multiplier is 2, would be 10. Okay. These, I'm like, oh, I can go 30 divided by 6, that's 5. 72 divided by 6 is 12. So 13 times 5, well, that would be like 13 times 5. I'm drawing a blank. 65. Oh, wait. Oh, I divided by 6. Sorry, 13 times 6. Okay, sorry, is 78. I don't know. What do you think about these? Yeah, this one here, like a 3, 4, 5, right? Because with the multiplier being 5, that means this would be 25. What about here? That first one's kind of obvious. Like, clearly they both end in 0, so you have like 7, 24, so 25. So this would be 250. Okay. But all Pythagorean triples are, like, it's a shortcut. And, like, honestly, like, I don't think you should look at a problem and be like, ooh, is this a triple? Like, I think if you just naturally recognize it, like, if it's instant, that I would just use, like, these triples and a multiplier to find the missing side. Otherwise, the Pythagorean theorem is still going to work. It's just once you can easily recognize a triple when you see one, like it does really quicken things up. And then in later classes when you're studying trigonometry, it it really is a really good shortcut to know. Okay, but it's just a shortcut. Pythagorean theorem still works, okay? I just wanted you to see this, and that's how I break it down. Bye.